Welcome back. And in this episode of the Griffin, remember when I said before, about no surprises at the end? Wrong. -5. Thanks for playing. Ain't gonna happen that way. Because when I thought that this deck was, should operate correctly, and then I started getting into checking some things, and things weren't where they were supposed to be, found out that there was some more stuff wrong. But again, until the voltages were correct, I really couldn't go that far. Well, now we got deep into it, and here's what that looks like. Don't have a schematic. There ain't going to be a schematic. There probably aren't anymore. It's at the bottom of somebody's bird cage by now. But the way this power supply is set up basically split the function of the power supply. It comes off the rectifier tube to the first cap, and then everything is pretty much just paralleled all the way down. And it's kind of cool just being able to look at the circuit. You can see what's going on. For the record, no pun intended, you can see how the signal is going from stage to stage to stage. That's what makes it so cool. I mean, when you can just look at it and it talks to you, okay? Sometimes they say bad words. Before I started recapping this chassis, I took a bunch of readings. Wanted to actually just sort of record what the voltages were at the various stages throughout the chassis prior to recapping it. And it's a good thing to do. I prefer doing that. Of course, the downside to that is that, the caps were pretty much toasted. This is where we're at. I took all those readings, and one of the things that I noticed prior to recapping it was that even when this was put into the play mode with no tape on it, just put into play mode, going to the record head and the erase head, I had a signal there. Yeah, it was 70 kilohertz, and so on the record head, which would have been record bias, there was 3 volts peak to peak going to the record head. There was 10 volts peak to peak on the erase head, and had I put a tape on there, and the worst case scenario would have been to put an alignment tape on there, because that record bias and erase current would have damaged the tape. It would have partially erased it or maybe even fully erased it. In any case, now that it's all recapped, those signals aren't there anymore. The oscillator isn't on. So that's a good thing. But what we want to do now is to investigate something else that came up, because now that it's all recapped and you go to record mode, turns the oscillator on, there is no record bias for channel 2. Channel 1's there, 34 volts peak to peak on the record head for bias, and I'm getting 155 volts peak to peak on the erase head. But that's channel 1. Channel 2, nada. And it's like, okay, well, something's going on. I know the oscillator's working because it's on track 1. The relay energizes, but there's still no signal on the record head. So I want to figure out why. And the best way to do that right now is to go ahead and use the scope for tracing out where the signal isn't. There it is. There is the 70 kilohertz. What I'm going to do now is actually, I'm going to go ahead and put this in record mode. So now it's in record mode. Record bias, 30 volts peak to peak for channel 1. Erase current for channel 1. And now to channel 2, there is 42 volts and 149.6. What happens is that I can crank it up, okay, and then I'm running it down, but what happens is it gets to a spot and then it just dies. It goes down to 4.8. I mean, it's like I'm just moving this ever so slightly and it's there and then it's gone if I go back a little bit. That's a problem, and I would like to be able to actually reduce it, but it's going to depend on what kind of recording tape we're using, and that's going to set up the amount of bias that's going onto the tape, because the record bias is actually setting up the tape to accept the audio signal that's going to be planted on the tape itself. And it's mixed in these two capacitors here, because the record audio is coming through this preamplifier here and the oscillator's over here. So the oscillator is mixing through this capacitor to the audio, and then it's going out the head to be landed, embedded, or imprinted. I like imprinted, that's good. Imprinted onto the tape, okay? But certain different kinds of tape, I mean, like I said before, in the good old days, you'd probably have 185 nanowebers, okay? Nanowebers is like the field strength of the bias that's going onto the tape. And tape formulations got better and better and better over time, and you could put more signal onto the tape, okay? It's what we called hotter tape, you know, so 185 to 200 to 250 nanowebers. Shoot, I think they're using 320 and 600 now, okay? Because the formulations have improved, and they've been able to figure out what particles to use on the tape in order to accept the audio signal, but you have to like be breathing fire onto that tape to just get it biased so that the signal will be there. But it's going to be a much hotter signal. The tape won't saturate, in other words. So that's why you wanted to have a higher nanoweber rated tape. This is from 1962, okay? They weren't thinking in those terms back then. They were glad to have tape they could actually produce that actually would play back something you recorded on it. So that said, this is where we're at. This pot is not working, and I have a hunch. I think when all of these capacitors were bad and excessive current was being drawn through this discolored resistor, I think that the excessive current was also being pulled through that pot, and I think it burned out that pot. And there's a good way to test that theory. What I first want to do is confirm that these pots are in fact 10K. So what I'm going to do is measure this pot, and I'm going to measure from end to end, not the wiper, just end to end, okay? That should tell me what value the pot is. It's always a good idea to just like maybe put your voltmeter in here and find out where any of the voltages may remain. Capacitors get charged up, and once the cathodes and the heaters cool off, okay, the tube's not conducting anymore. So it tends to leave voltage in the capacitors, but it'll get your attention. All right, so let's see where we're at with this. Okay, and I can test this with it in the circuit because it's a rheostat. There's no lead on that far end. And this is measuring 10.6K. Just for grins and giggles, I could probably measure where the wiper is. Now, I don't want to measure it in the circuit. Okay, so what I want to do really is simply measure from the wiper to the unused end of the potentiometer, and then subtract that from 10K, and I'll know where the wiper is. 1K, which means that the wiper is at 9K. Okay, so the wiper is really at the far end with 9 kiloohms of resistance to the other lead. So now let's measure this pot. Okay, from end to end, nothing. It's an open, which means what's happening is it's not 10K ohms across this anymore. There is a break in it. And that also tells me that these pots are probably not carbon, okay? They are probably wire wound, okay? Another giveaway is the physical size of them. They're huge, okay? Now, granted, in 1962, everything was bigger back then. Don't chase that rabbit. Yeah. So anyway, they're big. Okay. My guess is they're wire wound, and it's 10K ohms from end to end, but there's nothing there. Yeah. So there's a break between the wiper and the unused lug on this potentiometer. Gonna have to replace that. And I would love to know for sure that it's a wire wound, but just the physical size of that and the nature of the circuit that it's in, I'm guessing it's probably 2 watts minimum. So 2 watt wire wound 10K pot. That's on the shopping list. And that's where we're going to have to go next before we do much of anything with the record circuit that's in here. Now, let's just take a look at this thing. This is commonly referred to as a potentiometer, and In this particular case, it's being used as a rheostat, right? Because we're only going to be using 2 of the 3 leads that are on here now. The resistance is going to be used between this end of the stator and the wiper, okay? So it's only going to be basically a variable resistor as opposed to the wiper traveling between potentials, hence potentiometer. But let's take a look at this, because this is the one that's bad. And there. Okay, so we got the cap off. Let's take a look inside this thing. From these lugs on the ends, okay, here and here, on the inside of this thing, what we've got is a stator that runs from that lug all the way around to this lug. So the resistance in this particular pot is actually going to be 10 kiloohms. Okay, 10K. But the really interesting part about this, if I can get this in focus, you're going to see that this stator is actually wafer thin, and it has wire wrapped around it laterally all the way around. So if you were to take that wire off of that stator and stretch it out, it's going to be feet long. It's also typically of this vintage, it's going to be probably nichrome wire. And what ends up happening is that this top edge is bare so that this wiper can actually slide from end to end. These little tiny wires that are wrapped around that stator burned out. So we replace it. There's 2 more pots involved with this oscillator circuit. These 2 are for bias. These 2 are for controlling the oscillator. You have a pot right here that is for the oscillator itself. Now the oscillator, it's a dual triode, so when it goes to turn itself on through an RC time constant circuit in order to develop the frequency we're talking about, you're going to have a resistor and a capacitor that are going to create a time constant, which creates a frequency. But because of the way the oscillator is designed, one triode goes positive part of the cycle, the other triode then conducts in the opposite direction. So you get a sine wave, okay, at 70 kilohertz. This pot right here actually controls the balance between the 2 triodes, because you don't want a real high peak here and then just a lesser one. So that pot is actually going to adjust the balance so that the sine wave is symmetrical. And that'll be important in order to create a lower distortion in the recording process. This pot right here acts as a dummy load for the oscillator when you're only recording 1 track. This deck is capable of stereo, but it's also capable of recording 1 track at a time. What happens is that when you change your track recording selection, okay, you can select 1 channel, we'll just say channel 1, stereo, channel 2. Well, stereo is going to be using all of that current to bias 2 record tracks on the head. It's also going to be loading up for the erase head to be erasing 2 tracks at a time. But when you go to 1 track, you don't want to feed all of that signal, bias, erase current to 1 track. So what it does is it will take what isn't going to channel 2, for example, and it actually will then send it to this dummy load through this switch. The switch will switch out that channel for recording and erase, and it basically loads it up onto this resistor here, which is just like a dummy load. And what this pot does here, it's going to simulate the load that isn't there because of the head switch for recording and erase. But it's burned out too. That's a 5K pot. So we're going to have to find a wire wound 5K 2-3 watt potentiometer in order to replace that one, because the same thing that burned this one out burned that one out. And that's a bummer, but it's not a deal breaker. And so we'll be replacing 2 pots, and it'll try not to get them confused. Having discovered that bad capacitors can really damage other components, and having discovered that, these parts are on order. In our next episode, though, I kind of make up for lost time and deal with some side items on this chassis. Okay, yeah, light bulbs, yeah, little tiny ones. All right, we're going to take care of that while we're waiting for the parts to arrive. I hope you're going to like it, all right? If you do, give us a thumbs up. Subscribe to the channel, let you know when the new episodes are dropping, and I really appreciate your comments. All right, keep them coming, because, you know, it helps us basically get a better idea of exactly what you guys want to see. And that helps me out, because then I don't get lunch after all. Patreon subscribers, really appreciate you. All right, merchandise, as you know, we're going to have some stuff. All right, I've got some great ideas about merchandise. Okay, it's just not in the budget, but it will be at some future date. Okay, being a Patreon subscriber gives you access to detailed episodes, gets down into the weeds, and actually shows you some things that you might not have thought of otherwise. That's important. Okay, so we appreciate it. We're going to give you something back. We'll look forward to seeing you in our next episode.